Hello, good afternoon ladies and gentlemen. Welcome to my presentation. Let me introduce myself. I am a marine engineer with second engineer degree and a master student of marine transportation engineering at Istanbul Technical University. As you can see on the screen, our topic is evaluating the risks of marine turbocharger failure with using fuzzy fault tree analysis method. I will begin with environmental effects of marine engines, especially the negative effects of combustion. Then I will move on to working principles of turbocharger system. Next, I will try to explain fault tree analysis method, and after that we will see the application of fuzzy fault tree to our research. Finally, we will discuss the results. Now let's start with marine turbocharger system. Most ships use a diesel engine as their propulsion method or prime mover. From handy to ULCC, almost every types and size of vessels use different types of turbochargers. Not limited with main engine, also diesel generators have turbochargers. A turbocharger is an essential part of modern diesel engines. The combustion process of the diesel engine results in emissions that contain pollutant gases. These pollutants could have harmful damages like acid rain, ozone depletion, greenhouse gases, and human health issues. Efficiency and environmental impact of the diesel engine depend on the air-fuel ratio. The main principle of turbocharger is to recycle the wasted kinetic and thermal energy of the exhaust gas that comes from combustion in the cylinders. I will try to explain the most commonly used turbocharger system. These are some essential parts of a marine turbocharger. Exhaust gas released from the engine is channeled to the inlet casing, you can see as number 4, and by means of nozzle, the gas being expanded and accelerated that serves to convert energy into rotational move by number 1, and the motive force of the turbine directly drives the compressor impeller, which is number 2. As the compressor wheel rotates, external air is channeled through the silencer, it's in number 8, then the pressurized air will follow the air conditioning and the engine air supply line, which depends on the type of engine. The system on the left shows an example of two-stroke engine with uniflow scavenging system. Red sections shows us combustion process and exhaust gas formation, and blue section show us intake air from turbocharger system goes through charge air cooler and mist catcher to air ports of cylinders. You can see here the development of over the 70 years of turbochargers. Before I move on, I would like to summarize what I've said so far. Turbochargers use the waste energy to supply compressed air to the engine. Thus, the weight of the air in the air-fuel ratio increases, its temperature decreases, and the efficiency of the engine also increases. As a result, the amount of specific fuel consumption is reduced and harmful exhaust gas emissions are also reduced. Let's now move on to our method. Fault tree analysis is basically a frequency calculation method. As you're probably aware, when we are talking about safety, we are interested in trying to measure risks. Because risk is the thing that we want to control. Risk is basically something bad happening or something we don't want to be harmed, like other people or the environment or some kind of cost-related issues. In the maritime industry, these are referred as undesired events, which has 4 subtitles: unsafe condition, near miss, incident, and accident. A fault tree is a logical diagram that is created by decomposing of internal and external root causes. You can see here an example of fault tree structure. Fault trees have a basic structure. The top event in any fault tree is the failure event. Basic events represents the lowest level of each branch in the fault tree. The top event is usually connected to basic events through gate events. The major task is construction a fault tree, and it requires the participation of experts from several and different disciplines. The analysis can be performed using one of two approaches, either top-down or bottom-up. To demonstrate the calculations of minimal cut sets, the structure shown in figure from previous page is used to apply the top-down approach. As you can see from the equations, 5 minimal cut sets have been identified. After identifying the minimal cut sets, the probability of the top event connected by gates are shown in these two equations. The most difficult part of performing a quantitative fault tree analysis is actually finding the probability of basic events. Thus, a more practical approach is needed, and I want to explain that how fuzzy logic can be used to demonstrate a more realistic and more practical method for expanding quantitative fault tree in our research. The first stage of this study is to determine potential risks for marine turbocharger failures. Here you can see 4 major components of turbochargers and 12 risk factors that could cause failures were listed. We used feedback from experts to construct a fault tree. I would also like to draw your attention to the lower half of the chart. You can see our 12 failure risks as basic events. These risk factors were evaluated by 4 experts to understand their probability of occurrence. The weighting scores of these experts have calculated from their characteristics weighting factors. There is a need to apply fuzzy sets and convert these terms into numerical, because these experts will give the possibility of these risk factors in linguistic terms. Convergence scale for linguistic terms and trapezoidal fuzzy numbers of possibilities is shown in this table. These 7 terms are used to convert linguistic terms to fuzzy numbers. You can see here the judgments of marine experts with linguistic terms. These expert opinions in linguistic terms could be used to calculate the possibility of each failure risk. For converting linguistic terms to fuzzy numbers and analyzes individual expert opinions, we can use the similarity aggregation method. I don't want to lost in calculations here. They are quite complicated. We placed all these formulas in Excel and continued the analysis through that Excel form. Still, there are a few important points I should mention. A minimal cut set is a collection of basic events that contain the fault tree's critical elements. It shows that the system becomes more dangerous as there are more minimal cut sets, and the importance level of minimal cut sets is used to calculate the sensitivity of top events probability. As the graph shows us the results of computing our expert opinions, and the final value is total of occurrence probability of all events, because our system only has OR gates. The final value is 0.1355, and that means the occurrence probability of top event, which means turbocharger failure risk is 13.5%. And we can list the risk according to likelihood of occurrence. As you can see, the first 3 likely risks. Well, this brings me to end of my presentation. As a final point, I would like to highlight one key issue. Why do we concern about the efficient use of turbocharger system? As I have already explained before, turbochargers are equipment that are produced and used completely to increase energy efficiency. They use only waste kinetic and thermal energy and provide us more recycled energy. That is the most important point of the topic. If we succeed to use this energy, we can decrease fuel consumptions and we also reduce the damage to the environment. Thank you for listening.